Okay, YouTubers and do-it-yourselfers. My name is Mark. I'm a do-it-yourselfer and somebody that tries to do as much as they can on their own projects, even more complicated stuff that usually most people would pay other people to do for them. Well, I have a 1969 Ford truck F-250, and it's a camper special. It has two gas tanks, one underneath the bed of the truck and one behind the driver's seat. And I was building a set of headers for it. It has an FE, a 390 cubic inch motor in it with a 2-barrel Holley 500 CFM carburetor on the 2-barrel manifold, and it still has the stock exhaust manifolds on it, and I'm going to swap it out with custom made headers for it, and I got one side done. So I wanted to share how I built it myself, because even if you're in the market for that particular chassis combo, like the one I have, it's very hard to find a header that will clear the factory starter on the passenger side. Sanderson does make a header that they claim that will fit on the driver's side, and so I mean that's okay, but on the passenger side they have a header that they say you'll most likely have to buy a mini starter. Okay, so there's a clearance problem there, and also it probably gets really close to the starter and will cause it to heat up and burn the starter out, which is not good. So what I did is I went online and I looked at different header stuff, and I kind of came up with my own idea how to build my own header for the passenger side of the 1969 Ford Camper Special F-250. So this is what I came up with, and I'll show you. Those exhaust ports, unlike the small block Chevy, are not round. They're rectangular, okay? And so they're basically 2 inches, 1 inch 900 tall by 1 inch 400 to 300 wide, okay? And so what I did is I used some 1.5 inch by 2 inch square steel tubing, 120 wall, okay? And I made pie cuts. And here's the pie cut. And you can see it really well if I hold it like this. You can see that on both sides of the cut, that is about an 8.5 degree cut. And when you place these cuts together, it starts to create a turn. And so that's what I did. I made a bunch of these cuts, and I'll show you how I did it. But anyways, it ends up building a turn like this. Okay, and then I spot welded them. Okay, and I would suggest when you do spot weld these that you weld them where you can still put it on a flat surface and it won't rock on the weld. Spot weld it in 4 places, top and bottom, on both sides of the seam. Okay, right there, one on top and one on bottom. Okay, and then flip it around and do the inside of the turn the same way. You can also use magnets that you can get from Harbor Freight real cheap, that you can place over the top here, like right there, and it'll hold it together while you're, setting up your spot welds. Okay, and by doing that, you'll still be able to put this on a bandsaw, okay, and a flat bandsaw surface, and then cut the end, and that way you can set it like this, flat on the bandsaw, and cut the end, because you'll still have to cut one end when you're, when you get your final measurements to make them fit. But this is what I came up with, is this type of design here. Okay, and this is made out of a combination of 1.5 by 2 inch tall and 2 inch by 2 inch square tubing. Okay, it's all 120 wall. I bought the flange from Sanderson Headers. This flange, I just took it down there, South San Francisco, and they ground the welds flat so it would have a nice seal. No gasket required. All I got to use is high temp silicone, okay? And this here is what I ended up with in a design. It starts off at the top with 1.5 by 2 inch, and by the time it gets to the second port heading backwards, it turns into 2 inch by 2 inch. You see that blend right there? Okay, and then when it gets to the back on the very final port, that one right there where the tube is, it blends in. It blends in, I don't know if you can see it, right at the seam where the tube meets, you know, where the transition from square tube 2 inch by 2 inch to, and this is 2.5 inch round tube that fits it, and so it's kind of angled back to make that sharp turn that's necessary, okay, to help it angle back. And then so it's kind of finished, and it came out pretty nice. I'm real happy with it. I built drag race motors. I had a drag race car, had a flow bench, boarded my own cylinder heads. I had die grinders and all the tools to do that, even valve jobs and all that. I came up with this design so I know kind of what engines like on the exhaust flow and the design of it. It all blends back. Like this last port right here, you know how notorious the factory Ford exhaust manifolds are. They get really restrictive, and I think that's what really kills the power in the Ford FE motors until you get a good exhaust design. All of these blend, like this one here also, they blend. I don't know if you could see it, but they blend into making a smooth transition to force all the gas exhaust pulses to head in the same direction instead of slamming into each other and then trying to be forced out the rear, which the factory exhaust manifolds are notorious for, and that's why the engine power really sucks. They say when you get a good header on the engine, on the FE motors, you'll gain 30 to 60 horsepower depending on your cam timing. So this is what I came up with, and I thought I'd share it, and I'll put it on YouTube, and it's all going to blend into a 2.25 inch system, and I'll show you real quick here in the garage how I made these pie cuts. We'll go into the garage, and it's real simple. I made my own jig out of plywood, and then this Harbor Freight tool, the saw, and there's the metal right there. Let me grab a light, get a little more light on the subject here. But that bevel cut in the plywood is about 8.5 degrees, okay? And then you poke out your metal out there to expose it, and then you run this saw, which is a really good, cheap metal cutting skill saw from Harbor Freight, okay? It has really good blades on it, and you'd be surprised how well it cuts steel. It just cuts it like it's cutting wood almost. Really cheap, and works real good, and I've been real happy with it. I just buy new blades when the blades get dull. But anyways, that's how I cut the pie cuts. And you cut one angle, and then you flip the bar around. You flip it around 180 degrees, and then you cut the other angle, okay? And that's how you make your pie cuts. So all the walls and the inside and the outside of the walls of the tubing will match up when you weld it, okay? So it makes like a smooth transition. But anyways, that's what I've been doing and stuff, and this is my little messy workshop that I've been working in. But anyways, and then the bandsaw, this bandsaw right here comes in real handy. This is also a Harbor Freight one, and I had to true the base of it right here, the base of it, with a little washer shim on one side where those two screws go, and to make it square with this blade. That's what the only thing I would tell you to watch out, because these Harbor Freight tools, they're not square, so you have to square them up yourself. But anyway, this is Mark, just a do-it-yourselfer that tries to do as much as can, save money, and also learn at the same time. So I hope this helps, and if you have any questions, and I can try to help you out, and good luck doing your own headers. They're kind of difficult. I would suggest when you buy header material, get the thicker material you can. A lot of header companies sell 18 gauge, which is too thin. It's only about 40 thousandths. Really, really easy to burn through with a MIG welder. Okay, you want, that's why I chose the square tubing on my setup. And I would say if you can find 14 gauge tubing, that's what you would want to use, which is a little bit thicker. It's almost about 80 thousandths, and so that less likely to burn through. And you can overlap your tubes and weld right on the very top edge of the overlapping tube, and you're less likely to burn through. Okay, so that's what I suggest, and I hope this is helpful, and I'll let you know how everything works out once I get the headers on the truck and everything. But at this point, I've got it basically set up to where I can go to the next step. All right, take care, and I'm checking out.